In this section, we will be looking at linear equations in two variables. We're going to start by reviewing how to graph on the plane. So graphing points involves finding the intersection where the x and y coordinates meet. Points are given as ordered pairs x comma y in parentheses. The plane has two axes, an x-axis and a y-axis. The x-axis is horizontal and the y-axis is vertical. Where these two axes meet is called the origin, and it has the coordinates 0, 0. So with these two axes, the x and y, the plane is broken into 4 sections called quadrants. In the upper right, we start with quadrant 1 that has both positive x and y values, because from the origin, positive x is to the right and positive y is up. So if we are up and to the right, that's quadrant 1. Up and to the left is quadrant 2, which has negative x values but positive y values. Lower left quadrant is quadrant 3, which has negative x and y values. And then we have quadrant 4, which has positive x values and negative y values. We're going to start with graphing some points. So we're going to plot the points on the graph. First up, we have 3, 5. So the 3 is going to be our x value, and 5 is going to be our y value. So I go to positive 3 on the x-axis, and then I find positive 5 on the y-axis, and where those two intersect is going to be the point 3, 5. So from the origin, I went to the right 3 and up 5, and that's going to be my point. Negative 2, negative 1, I start at the origin, x, negative 2, so that's 2 to the left, and y is negative 1, so I go down 1, and that's a point. 6, 0, we start at the origin and go 6 in the positive x direction, and place a point there. Negative 4, 5, starting at the origin, we go to the left 4 and up 5. 1, 2, 3, 4, 5. 1, negative 3, we go to the right 1 and down 3. In 0, 2, we don't move left or right at all, we just go up 2 and place a point there. Graphing points is going to be the basis of everything we do graphing, so it's really important to understand how to graph points. In this unit, we're going to be focusing on linear equations, linear functions, and the graphs of linear functions are straight lines. They could be angled, they could be horizontal, they could be angled the other way, they could be vertical. So these straight lines are linear equations. When we're talking about linear equations, a very important aspect of them is slope. The slope of a function can be considered the average rate of change between 2 points. And because that is constant for linear equations, the slope is always the same, and we have a formula for it. We use the letter m to represent slope, and the way we find slope is by taking the change in output divided by the change in input, sometimes written as delta y over delta x. So those little triangles are deltas. They're a capital delta, the Greek letter. The actual formula mathematically that we use is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, sometimes just read as y2 minus y1 over x2 minus x1, or we think of it as rise over, where x1, y1, and x2, y2 are 2 points on the line. So here we want to find the slope of this line, and I'm going to look at it 2 different ways. First up, I'm going to think of rise over run. What I mean by that is, how do we get from one point to the other? If we're not going in a straight line from one to the other, if we want to go vertically and horizontally. So how far up and down do we have to move, and how far left and right do we have to move? Well, from here, we have a y value of 7. We're going down to a y value of 4. So we're going down 3 in the negative direction. In the x direction, we're going 1, 2, 3, 4. So we're going 4 in the positive x direction. So our slope should be our rise over our run, which is -3 over +4, or -3/4. But you might be asking yourself, what if I went horizontal first, then vertical? So we go forward, then down. Well, we're still moving 4 in the positive x direction and 3 in the negative y direction. So either way, we're looking at -3/4. Now let's look at this based on the actual formula. M equals y2 minus y1 over x2 minus x1. I have 2 points on my line. 0, 7 is my first point, so I'll label that as x1, y1. 4, 4 is my second point, so I'll label that as x2, y2. So if I plug in my values, y2 is 4, minus y1, which is 7, over x2, which is 4, minus x1, which is 0, which gives us -3/4, the same value we had thinking of it as rise over run. We're going to practice a little more with that formula for the slope of lines. So find the slope of the line that passes through the points 3, 6, and 4, 8. So if I label them x1, y1, and x2, y2, then our slope m is y2 minus y1 over x2 minus x1. This is a formula you will want to memorize, no questions asked. This one is important. So if I plug in my values, that will be 8 minus 6 over 4 minus 3. 8 minus 6 is 2, 4 minus 3 is 1, and 2 divided by 1 is 2. So our slope is 2. We're going to do it again for the second set of points. So we want to find the slope between the points -3, -7, and -9, 1. We have x1, y1, x2, y2. Our slope will be 1 minus a -7 over -9 minus a -3. Well, subtracting a negative is the same thing as adding a positive. So this is really +7 over -9 plus a +3. So that's going to be 8 over -6. That fraction reduces if I divide the numerator and denominator both by 2 to 4 over -3. Now, a neat little thing about negative fractions is it doesn't matter whether you put the negative in the numerator, the denominator, or out front. As long as there's just one negative sign, then they all mean the same thing. So 4 over -3 is equal to -4 divided by +3, which is equal to -4/3. They all mean the same thing. Now we're going to find the slope of the line that passes through the points -3, 5 and -3, 8. So our slope will be 8 minus 5 over -3 minus -3. That's 3 over 0. Well, let's see what happens when I type 3 divided by 0 into my calculator. It gives me an error saying I'm dividing by 0. Well, dividing by 0 is something that's not allowed. And there's a nice little Easter egg provided via Siri that I want to share with you, so you can get a little chuckle out of why dividing by 0 is bad.
What is 0 divided by 0?
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
So we can't divide by 0 because we don't have friends. That's what Siri is telling us. All right, so let's try this other one. It says to find the slope of the line that passes through the points 3, 5 and 8, 5. So our slope will be 5 minus 5 over 8 minus 3. That's going to be 0 over 5. Let's try typing that one into the calculator. That's just 0. And we're okay with having a slope of 0 because 0 is a number. This 3 divided by 0, though, that is something that we're not able to do. So we say that this slope is undefined. We're now going to take a look at a little animation sort of thing that shows us how slopes kind of relate to each other. How different slopes change the look of lines when we graph them. So right now we are looking at the equation y equals mx plus b. M, remember, is our slope. This little slider here is going to allow me to change my slope. So if I move it to the right, my slope is going up. The higher I go, the steeper my line is getting. So it's getting closer to vertical. As we go smaller, we're getting closer to horizontal. Once we hit 0, we are completely horizontal. So that's what a 0 slope means. We're being completely horizontal. When we go negative, we're just going to slope in the other direction, kind of downward if you want to think about it that way. And the more negative we go, the steeper downward we go. So that slope is really important. And I want you to try to think about how we saw what a 0 slope does. That's horizontal. I want you to think about what an undefined slope might mean in terms of what the line would look like. So when we were first talking about slope, when we introduced the idea, we said that slope is an average rate of change. Well, in this case, we can tell that all the data doesn't fit a completely straight line, but we can still use slope to represent the average rate of change. So in this case, we want to find what is the average rate of change in a child's height between ages 2 and 6. So first we find at age 2, the height is 31. And at age 6, the height appears to be 40. So to find the average rate of change, I want to find the slope between these 2 points. So I'm going to take 40 minus 31 over 6 minus 2. That is 9 over 4. Now most of the time when we're talking slope, fractions are the way to go. However, in this case, we're trying to find the average rate of change in a child's height. 9/4 doesn't mean a whole lot to us. So what I want you to do is kind of think about what this 9/4 represents. We had our y values on top, the 40 and the 31. Those were the height in inches. So this represents 9 inches. 6 minus 2, that was the age in years. So this is 9 inches over 4 years. If we take 9 divided by 4, that's going to give us a decimal of 2.25. Looking at the units, this is going to be inches over years, which we would write as inches per year. So on average, the child is growing by 2.25 inches per year. Now that doesn't mean that they're growing by 2.25 inches every year. It just means on average, between the age of 2 and 6, the child is growing by 2.25 inches. Next, we're going to look at the average rate of change of the child's height between the ages 13 and 16. So at age 13, the height appears to be 52. And at age 16, the height appears to be 62. So the average rate of change, or our slope, will be 62 minus 52 over 16 minus 13, or 10 divided by 3, which is roughly 3.33 inches per year. So you'll notice that the slope in this later part was a lot higher than it was before. And a lot of it happened between the years 13 and 14. The kid shut up. So the average kind of tries to level things out and makes things say just, if it were the same every year, what would that change be? That's what average rate of change does. We're going to take a look at an application problem involving slope. The population of a town has declined. In 1990, it was 60,000. In 2000, it was 58,000. What is the rate of change of the population? When I see this, I see it as two pieces of paired information. We have the year 1990, which is paired with a population 60,000. And we have the year 2000, which is paired with the population 58,000. So if we want to find the rate of change, we're going to find the slope. So I'm going to take 58,000 minus 60,000 over the year 2000 minus the year 1990. That gives us negative 2,000 divided by 10, which is negative 200. Now, kind of like in the last problem, how we looked at the units, we're going to look at the units for this one as well. The 58,000 and the 60,000, those were the population. And population is measured in number of people. This 2000 and the 1990, those are years. So that means our units are people per year. So the way we would really interpret this is that the town is losing 200 people per year. That's why it's negative. So now we're going to get into writing our own linear equations. We've talked about slope, but there's another important piece to this equation. Pun totally intended. We typically write linear equations in slope-intercept form. This is our favorite form because it gives us a whole lot of information all at once. Slope-intercept form is the form y equals mx plus b. This is one of our favorite equations. We've had it memorized forever. M is our slope, and b is going to give us information about our y-intercept. In application problems, this y-intercept value is our initial value, what we start with. And we'll see plenty of examples using this. However, another useful form is point slope form. And that says y minus y1 equals m times x minus x1. This form looks a lot scarier than slope-intercept, but in a way, it can be a little bit nicer to work with. And I want to point something out. Our formula for slope is m equals y2 minus y1 over x2 minus x1. If I multiply both sides of this equation by x2 minus x1, we'll have m times x2 minus x1 equals y2 minus y1. If you erase the 2's, you have point slope form. Y minus y1 equals m times x minus x1. So this is going to be a useful form because you'll see. We will use both. Something else I would like to introduce you to is VUX-HOI. This is a little acronym to help you remember the two special types of linear equations. VUX, V-U-X, stands for vertical lines, have an undefined slope. Their equations are in the form x equals a number. So we talked about how zero slope gave us that horizontal line, and I told you to think about what an undefined slope might look like. That's going to give us a vertical line. HOI, H-O-Y, stands for horizontal lines, have a slope of 0. Yes, we used an O to represent a 0. Ha ha, math stuff. And their equations are in the form y equals a number. And that's going to give us our horizontal line. So keeping in mind our slope-intercept form, we're going to take a look at these equations and see if we can find the slope of the lines. Well, slope-intercept form is y equals mx plus b. So if I want to know the slopes of these lines, then I'm going to have to get y by itself. In this first equation, x plus 3y equals 33, I'm going to start by subtracting x from both sides. Then I'll have 3y is equal to negative x plus 33. To get the y completely alone, I'll divide by 3. So y is equal to negative x divided by 3 plus 33 divided by 3 is 11. Now the slope is the coefficient on x, the number multiplied by x. Well, there's a negative in front of the x, and it's divided by 3. If I think of this negative x as negative 1x instead, it might be easier to see that my slope is a negative 1/3. Moving to the right, we have negative 6x minus 4y equals 25. I'll start by adding 6x to both sides, and we will have negative 4y is equal to 6x plus 25. Then if I divide both sides by a negative 4, we will have y is equal to 6x divided by negative 4 plus 25 over a negative 4. Now I'm really only interested in the slope here, the coefficient on x. The number sitting in front of x is 6 over negative 4. So my m is a negative 6/4, which if I divide my numerator and denominator by 2, is a negative 3/2. Y equals 2. That's one of our special equations. So we want to think VUX-HOI. We have y equals a number. That means we're in HOI. This is a horizontal line, and it has a 0 slope. Another way we can show this is if we write it as y equals 0x plus 2. That means the same thing as y equals 2, because no matter what x is, if we multiply it by 0, we get 0. So these both mean y equals 2, and now we can see that the slope is 0. X equals 1 should also trigger something because we're used to seeing y equals. Having x equals, we know something's funky. If we have x equals a number, we are in the VUX of VUX-HOI. We have a vertical line with an undefined slope. So our slope, m, is undefined. So now that we're a little bit more comfortable with slope, we're going to find the equation of some lines. First up, we're going to find the equation of the line with a slope of negative 3 that contains the point 0, 5. Now I'm going to do this one way, and I'll do the next one a different way, and then you can kind of choose which one you prefer. I'm going to do this one using the equation y equals mx plus b, because that's the one that students tend to remember. They gave us my m, my slope, and then they gave us an x and a y value. So I'm going to go ahead and plug those in. My y value of 5 is equal to our slope m, which is -3, times our x value of 0 plus b. And I want to solve for b. I want to get b alone. So that's going to be 5 is equal to -3 times 0 is 0 plus b. So we are getting b is equal to 5. Now that I know what my slope m and what my y-intercept b are, I can write my equation in the form y equals mx plus b, replacing my m with a -3 and replacing my b with 5. That is the equation that has a slope of -3 but contains the point 0, 5. In the next one, we want to find the equation of the line with a slope of 1/2 that contains the point 2, -3. And I'm going to approach this one a different way. I'm going to use our point slope form, which is the y minus y1 equals m times x minus x1. This equation might be a little bit harder to remember, but you don't have to remember after for b to put it back in the right form. So I'm going to start by plugging in my values. Y minus, this point is going to represent my x1, y1. So I'll have y minus a -3 is equal to my slope 1/2 times x minus my x value of 2. Y minus -3 simplifies into y plus 3. And if I distribute my 1/2 through the parentheses, I get 1/2 x minus 1. To get y by itself, I'm going to subtract 3 from both sides, and we get y is equal to 1/2 x minus 4. Both of these ways are completely wonderful and beautiful, so use whichever one you prefer. Next up, we're going to find the equation of the line that passes through the points -3, 5 and -3, 8. So this time they didn't give us our slope. We need to find the slope first. So if I do my y2 minus y1, that's 8 minus 5, over my x2 minus x1, -3 minus a -3. This is that case where we're dividing by 0. And if we divide by 0, then our slope is undefined. If we're dealing with a line that has an undefined slope, then we are in the VUX of VUX-HOI. It's a vertical line that has an undefined slope. The equation is going to be x equals a number. If you look at the 2 points that this line goes through, they both have an x value of -3. So my equation is x equals -3. You probably won't be too surprised by the next one. We want to find the equation of the line that passes through the points 3, 5 and 8, 5. So starting with my slope, I will have 5 minus 5 over 8 minus 3, which is 0 divided by 5, which is 0. If we 0 slope, then we are in the HOI of VUX-HOI. Horizontal lines have a slope of 0, and their equations are y equals a number. If you look at my 2 points, both of them have a y value of 5. So our equation is y equals 5. But they're not all horizontal and vertical lines. We do have other slopes too. So this time we're going to find the equation of the line that goes through the points 4, -8 and 36, -2. Starting with my slope, I'll have a -32 minus a -8 over 36 minus 4. That simplifies to a -24 over 32. And to simplify that fraction, I'm going to divide my numerator and denominator by 8, giving me a negative 3/4, and that's my slope. Now that I have my slope, I can use either the y equals mx plus b or the y minus y1 equals m times x minus x1 to get my equation. I just have to pick one point to use. I'm going to use the 4 negative 8 because I like smaller numbers if at all possible. And this time I'm just going to use the y equals mx plus b method. So my y value is negative 8. That's equal to my m value of negative 3/4 times my x value of 4 plus b. That means negative 8 is equal to negative 3 plus b. And if I add 3 to both sides, I get that b is equal to a negative 5. Now that I have my slope and the value of my y-intercept, I can write my equation. Y equals negative 3/4 x minus 5. And that's my equation. So now that we're a little bit more comfortable with linear equations, we're going to start looking at some application problems. A phone salesperson is paid a salary with commission on every phone sold. The pay in dollars P is determined by the formula P of x equals 15x plus 330, where x represents the number of phones sold. What is the initial value? What does the initial value mean in the context of the problem? What is the rate of change? And what does the rate of change mean in the context of the problem? So first up, the initial value. Back when we looked at y equals mx plus b the first time, we said that the b value is our initial value. So in this case, that's 330. But we want to know what this means. This formula is giving us his pay. So if x is equal to 0, so he's selling no phones, he still gets $330. So in the context of the problem, is he has a base pay of $330, or he gets $330 no matter what. Even if he doesn't sell any phones, he's getting that $330. When you see rate of change, you should think slope. The slope is the number attached to x, which in this case is 15. What does the rate of change mean in context of the problem? Well, that 15 is going to be this kind of idea of commission. He's going to get $15 per phone. If you think back to when we were doing how height changed over time, how we had inches per year, and then we did the population problem where we had people per year, this time it's dollars per phone because X is the number of phones and it's $15 times the number of phones. So that's where we're getting this $15 per phone. Here's another slope-related problem. At 8 a.m., the temperature was 64 degrees Fahrenheit. At 4 o'clock p.m., the temperature was 86 degrees Fahrenheit. What was the average rate of change of temperature between 8 a.m. and 4 p.m.? So we want to know how the temperature is fluctuating. So I could write these as ordered pairs, but I'm nervous because if I write 8, 64, 4, 86, the times aren't going to be quite right. So I'm just going to think of it as the temperature over time. So the temperature went from 64 to 86. So if I do 86 minus 64, that means that we had a temperature change of 22 degrees. The time change, we went from 8 a.m. to 4 p.m. That's 8 hours. So if we write this as temperature over time, that's 22 degrees over 8 hours. And if we divide that out, 22 divided by 8, we're going to get 2.75. And in this case, our units are going to be degrees per hour. So on average, the temperature was rising by 2.75 degrees per hour. We know it was rising because number one, it went from 64 to 86, and number two, because this is a positive slope. And positive means we're increasing, which is something we're going to keep looking at as we move forward. Next up, we're going to graph some lines. There are three really good ways to graph lines. We can use a table of values, we can use slope-intercept, or we can use x and y intercepts. And we're going to start with a table of values. What's nice about a table of values is that it always works for every graph ever. What we're going to do is pick some values for x, substitute them into the equation, and figure out what y has to be to make it true. So maybe x is 1, 2, 3, and 4. Well, if x is 1, we get 1 plus y equals 10. For that to be true, y would have to be equal to 9. If x is 2, then 2y equals 10, y has to be equal to 8. If x is 3, y has to be 7. If x is 4, y has to be 6. Each point is a solution to the equation. So when x is 1 and y is 9, this is true. When x is 2 and y is 8, this is true. So I'm going to plot these points. 1, 9, 2, 8, 3, 7, 4, 6. And I bet you can see that pattern forms a line. And we're talking about linear equations here, and my line's not very straight. So we're talking about linear equations, and we said right in the beginning that linear equations graph as a straight line. So it shouldn't come as a surprise to us that we got a straight line. One of my students' favorite ways to graph is graphing using slope and y-intercept. So we're going to start with the b value, a positive 3. That is going to be our first point that we plot, and we're going to plot it on our y-axis. So I want a positive 3, and I'm going to place a point. Now the slope is negative 1/2. Remember how earlier I said it doesn't matter whether the negative is in the numerator, denominator, or out front? When I'm working with slope, I really don't like it being out front, so I want to put it either in the numerator or denominator. It doesn't matter which. I just personally usually put it in my numerator. So I'm going to think of as negative 1 over positive 2. And I'm going to think of this as rise over run. Starting from my point that I've already placed, I want to rise a negative 1, which means go down 1, and run forward 2, 1, 2, and place a point. I can do it again. Rise negative 1, run forward 2, rise negative 1, run forward 2. And we get that same shape of a line. So slope and y-intercept can be a really useful way to graph, and it tends to be pretty quick. But we're not always in slope-intercept form, so it's not always easy to graph this way. Sometimes we are in what is called standard form, where we have some number multiplied by x plus some number multiplied by y equals a number, which isn't quite as user-friendly as the slope-intercept form. When we're in the standard form, it can be helpful to use x and y intercepts. The y-intercept is the point where the graph crosses the y-axis. Well, if we're on the y-axis, then our x value has to be 0 because we haven't moved left at all. So to find the y-intercept, I'm going to plug in x equals 0. That'll give me 2 times 0 plus 3y is equal to 6. But 2 times 0 is just 0, so that doesn't even count. If I have 3y equals 6, I can divide both sides by 3, and we get y is equal to 2. So if x equals 0, y equals 2, 0, 2 is going to be our y-intercept. The process for finding the x-intercept is very similar, except the x-intercept is where we cross the x-axis, so our y value is 0. So this time I'm going to plug in y equals 0, and we'll have 2x plus 3 times 0 is equal to 6. But just like last time, 3 times 0 is 0, so that doesn't matter. If we have 2x equals 6, I can divide both sides by 2, and we get x is 3. So when x is 3, y is 0, we have the ordered pair 3, 0. Always remember when we're doing points, x has to come first. I'm going to plot these 2 points, 0, 2, and 3, 0. And 2 points is actually enough. If I play connect the dots, I have a line. So that's how we graph using x and y intercepts. What we haven't graphed yet are horizontal and vertical lines. First up, we're going to graph y equals 3. So y equals a number. That means we are with the hoi of Vuxhoi. And that means we have a horizontal line, which you could probably deduce from the title. Y equals 3. The y value of 3 happens at all of these points. I don't care what x is, I just care that y is equal to 3. So that creates a horizontal line. Vertical lines have the equation x equals a number, in this case x equals -2. So if I find where x is -2, I don't care what y is, y can be whatever it wants to be, as long as x is -2, and that forms a vertical line. That's how we graph horizontal and vertical lines. So now we're going to see if we can find the equation of the horizontal line and then the vertical line that goes through the point 3, -4. I'm going to remind us of Vuxhoi. First, we were asked to find the horizontal line, so that gives us hoi. Horizontal lines have 0 slope. Their equations are y equals a number. So our equation will be y equals, and the y value in our point is -4. So this will be y equals -4. Then we want to find the equation of the vertical line. That puts us in Vux. Vertical lines have an undefined slope. Their equations are x equals. So starting with x equals, the x value of my point is 3. So we get x equals 3. They didn't ask us to graph it, so we don't have to. Graph is just there if we want it. Now we're going to see if we can kind of put some of these ideas together. We want to find the x and y intercepts for these equations. First up, we have x equals 4. And I think what's going to help us most is looking at a graph. X equals 4 is a vertical line that goes through an x value of +4. So 1, 2, 3, 4. It's this vertical line. We want to find the x and y intercept. Well, the x-intercept is where we cross the x-axis. That's this point here. It has an x value of 4 and a y value of 0. The y-intercept is where we cross the y-axis, but we don't. So this vertical line, x equals 4, has an x-intercept of 4, 0. But the y-intercept does not exist. There isn't one. You can probably imagine where we're headed with the next one. Our equation is y equals -2. So if we graph that, that's a horizontal line. Our x-intercept is where we cross the x-axis. We don't do that, so there's no x-intercept. Our y-intercept is where we cross the y-axis. That happens right here, and that point is 0, -2. So this equation, y equals -2, the x-intercept does not exist because there isn't one, and our y-intercept is at 0, -2. There's two more things we want to look at, the first of which are parallel and perpendicular lines. Hopefully you know that parallel lines are like railroad tracks are what people normally think of. Perpendicular lines are ones that meet at a 90-degree angle. But we've been worrying about equations and slopes. Parallel lines have the same slopes. So if you're looking at two equations that have the same slope, then their lines are going to be parallel. The slopes of perpendicular lines are opposite reciprocals. The way I think of this is flip the fraction, change the sign. So here are a few examples. Parallel lines have equal slopes. If the slope of line 1 is 1/3, the slope of line 2 is 1/3. If the slope of line 1 is 5, the slope of line 2 is 5. If the slope of line 1 is -2/7, the slope of line 2 is -2/7. Perpendicular lines, the slopes are opposite reciprocals. So if line 1 is 1/3, flip the fraction, change the sign, -3/1. If the slope of line 1 is 5, think of it as 5/1. So when we flip the fraction and change the sign, we get -1/5. And if the slope of our first line is -2/7, flip the fraction, change the sign, gets us to a +7/2. So we're going to be given a pair of lines, and we want to figure out whether they're parallel, perpendicular, or neither. The way we're going to do that is by finding the slopes of them. So first up, 6x plus y equals 7. We said that to find the slope, we're going to want to get y by itself. So I'm going to subtract 6x from both sides, and we'll have y equals a -6x plus 7. Now that the y is by itself, I can see the coefficient on x is -6, which is the slope of my first line. On this next one, we have x minus 36y equals 14. I want to get the y by itself, so I'll subtract 6x from both sides, and we will have -36y equals a -6x plus 14. Then I need to divide both sides by a -36 to get the y by itself. That's going to give us y is equal to -6 divided by -36 reduces to a +1/6. We still have our x. And then 14 over a -36 reduces to a -7/18. But I really don't care about that. I only care about the slope because we only want to know whether these are parallel or perpendicular or neither. The slope is 1/6 for the second line. So now that I know the slopes of both of them, I need to determine whether they are parallel, perpendicular, or neither. Parallel means they have the same slope, and that's definitely not the case. So they're not parallel. So I need to check perpendicular. Perpendicular is flip the fraction, change the sign. So if I think of -6 as -6/1, I flip the fraction, change the sign. I get 1/6. Hey, these ones are perpendicular. So these two lines are perpendicular because their slopes are opposite reciprocals of each other. In this next example, we have 2x plus 4y equals 2. I'm going to go ahead and solve for y. So I'll start by subtracting 2x from both sides. So 4y is equal to a -2x plus 2. And if I divide both sides by 4, I'll have y is equal to -2 divided by 4. That reduces to a -1/2 x. And then 2 over 4 is a +1/2. So our slope is a -1/2. Our second equation is 3y equals -3/2 x minus 6. To get the y alone, I need to divide both sides by 3. And if I do that, I'm going to have y equals negative 1/2 x minus 2. The slope of this line is a negative 1/2. They have the same slope. These lines are parallel. So you might be wondering, well, what would it look like if they were neither? If you had one slope of 2 and the other of 6/7, those aren't the same and they're not opposite reciprocals, so that would be a case of neither. So if they're not the same and not opposite reciprocals, that's going to be the neither case. So now that we have a taste of parallel and perpendicular, we're going to put that together with our equation writing skills. So find the equation of the line parallel to y equals negative 3/5 x minus 6 and through the point 5, 4. Well, we want to go parallel to this line, so we need the same slope. The slope of this line is negative 3/5, and if I want the same slope, that means my line also needs to have a slope of negative 3/5. Now that I know the slope and a point that it goes through, I can use my equations to solve. This time I'm going to use point slope form. So that's the y minus y 1. So y minus the y value of 4 is equal to my m value, negative 3/5, times x minus the x value of 5. That gives me y minus 4 is equal to, distribute my negative 3/5 through the parentheses, and we'll have a negative 3/5 x, and then negative 3/5 times negative 5 is a positive 3. If I add 4 to both sides of this equation, I get y is equal to negative 3/5 x plus 7. This line is parallel to the original, but it also goes through the point 5, 4. The second one says to find the equation of the line perpendicular to 2x plus 4y equals 2 and through the point 3, 4. So to go perpendicular, I first need to know the slope of this line. To know the slope, I need to solve for y. So I'll start by subtracting 2x from both sides. So we'll have 4y is equal to negative 2x plus 2. And if I divide both sides by 4, I'll have y equals negative 2 divided by 4 reduces to negative 1/2 x, and 2 divided by 4 is a positive 1/2. So we have y equals negative 1/2 x plus 1/2. This is the line I started with, and it has a slope of negative 1/2. I want to go perpendicular to it, so I need to flip the fraction and change the sign. So I flip it, and the 2 goes to the numerator, the 1 goes to the denominator. Change the sign, it was negative, so now it's positive. So my slope is going to be a positive 2/1, which is just 2. So now that I have the slope and a point on the line, I can go ahead and find my equation. This time I'm going to use y equals mx plus b. So 4 is equal to 2 times 3 plus b. So 4 is equal to 6 plus b, and if I subtract 6 from both sides, I get that our b value is a negative 2. Since the slope we want is 2 and our b value is negative 2, our equation is y equals 2x minus 2. Now that we have that, we're going to do a couple of application problems, and then we'll be done with these for now. Last year, Pinwheel Industries introduced a new toy. It cost $5,500 to develop the toy and $40 to manufacture each toy. Give a linear equation norm C equals mn plus b that gives the total cost C to produce n of these toys. So you'll notice this looks like y equals mx plus b. They just have us using c instead of y and n instead of x. The reason they did this is so that the variables actually make sense. We're using c for cost and n for number of toys. So we're going to have C is equal to our slope. The key word here to know which one's the slope is the word each. If you see the word per, or for each, or for every, that's going to be your key that that one's your slope, because the value is going to change every time that number changes. So 40 is going to be our slope. They wanted us to use n plus b, our initial value. Even if we don't produce any toys, it still costs $5,500 to develop. That's going to be our b value. So our equation is C equals 40n plus 5,500. We want to know what is the total cost to produce n equals 2,600 of these toys. So all I need to do is plug in 2,600 for n. So we'll have C is equal to 40 times 2,600 plus 5,500. I'm going to go ahead and plug that one into the calculator. We have 40 times 2,600 plus 5,500. 109,500. But this was the total cost, and that's being measured in dollars. So my answer to that particular question will be $109,500. Then we want to know how many toys can be produced with $189,500. This time they're not giving us an n value, but rather a c value, the total cost. So in my original equation, I'm going to replace the c with this 189,500. That's going to be equal to our 40n plus 5,500. And this time I'm going to solve for n because I want to know how many toys. To do that, I'm going to start by subtracting 5,500 from both sides. That's going to give us 184,000 is equal to 40n. And then if I divide both sides by 40, we get n is equal to 4,600. Since n is supposed to represent the number of toys, the way I'm actually going to answer this problem is by saying 4,600 toys. A college algebra student has test scores of 78, 82, 62, and 91, each out of 100 points. The final exam is out of 200 points. What is the lowest grade a student can get on the final to earn a B in the course? So we need to figure out an average. To find the average, we add them all up and divide by the number of things there are. So there's a 78, an 82, a 62, and a 91. The final exam, I'm going to let X be the score on the final. Notice that this final exam is worth more points. It's worth 200. So the way I'm going to think about this is this test, whatever score they get, we're going to multiply it by 2, and it's just going to be like 2 tests. So I'm going to make that 2x. I need to divide by the number of tests there are. 1, 2, 3, 4. Remember how this counts as 2 tests, so 5, 6. And again, the reason why we're doubling it is because it's worth 200 points. It's twice as important. We want this average to be at least 80. So that average needs to be greater than or equal to 80. I'll start by adding together these numbers in the numerator. 78 plus 82 plus 62 plus 1. That gives me 313 plus 2x over 6 is greater than or equal to 80. I can multiply both sides by 6, and I will have 313 plus 2x is greater than or equal to 80. I can subtract 313 from both sides, giving me 2x is greater than or equal to 167. And dividing by 2, we get x is greater than or equal to 83.5. So it looks like the student needs to get an 83.5 or higher on the final. However, we need to be really, really careful in problems like these. I don't think that they earned an 83.5 out of 200 points. What this score on the final really meant, was their percent score. An 83.5%. To figure out how many points that is, we need to double it like we did when we were figuring out the average. So if we take 2 times the 83.5, that gives us 167. So the student needs to score 167 points, because that would give them the 83.5%, and with the final being double the weight of the test, that's going to give the average of 80. Last one. An athlete begins normal practice for the next marathon during the evening. He begins running at 6 p.m. He finishes his run at 7:30 p.m. and has run 7.5 miles. Write an equation representing the distance the runner has run over time t in hours since 6 p.m. In hours since 6 p.m. So that means when time is 0, it is 6 p.m. So t is 0 because gives 6 p.m. because that's 0 hours since 6 p.m. An important equation to know here is that distance equals rate times time. D equals RT. They want us to give an equation for the distance d, so the d is going to stay. In terms of time t, so the t is going to stay. That means we need to find the rate. The rate that this athlete ran is going to be given in miles per hour, because that's distance divided by time. The distance run is 7.5 miles, and the time it took from 6 p.m. to 7:30 p.m., which is 1.5 hours. 7.5 divided by 1.5 is 5, and then our units are miles per hour. So the rate is 5 miles per hour. So our equation will be D equals 5t. What was his average speed over the course of the run? That's what we just found, the 5 miles per hour. Does that mean that the athlete ran 5 miles per hour the entire time? No. Maybe he ran 6 miles per hour and then slowed down to 4 and then sped up to 7. It averaged out to be the 5. How many miles did he run in the first 45 minutes? It is so tempting to try to plug in 45 for t here, but we have to keep in mind that t is representing time in hours. 45 minutes is 3/4 of an hour. So we need to plug in 3/4 for t. So our distance is equal to 5 times 3/4, which is 15/4, which if we do the division is 3.75. So how many miles did he run in the first 45 minutes? 3.75 miles. If he kept running at the same pace for a total of 4 hours, how many miles will he have run? We can use the same equation, D equals RT. We know his rate is 5, and if he's running for 4 hours, we can plug in 4 for t, and 5 times 4 is 20. So the distance is 20 miles.